space friends, this week I'm geeking out about supernovas. I totally love supernovas. Supernova remnants to me are some of the most beautiful images you can possibly look at when it comes to space exploration. And since a lot of us are spending a lot more time at home, a lot of us are also appreciating nature that much more. If you're like me, you've been going on a lot of walks and taking photos of flowers, and to me, supernovas are like the flowers of our cosmic neighborhood. They're just infinitely intricate and beautiful to look at, just like flowers. And also, like how flowers are part of our local ecosystem, supernovas are part of our cosmic neighborhood ecosystem. Only a few stars become supernovas at the end of their lives. When really massive stars run out of fuel, their core collapses in on itself under its own weight and begins to pack all of its matter into a denser and denser space, tighter and tighter, actually physically creating new elements in the process, like iron, until those elements become too densely packed that they actually recoil and trigger an explosion, thus creating a supernova that explodes out everywhere. That explosion of new material can get propelled out to 25,000 miles per second. Really fast. And in its process, it creates an entirely new ecology to galaxies, essentially creating more material for stars and planets to actually form. Another way a supernova can be formed is if a smaller dead star, like a white dwarf, is kind of neighbors with another star. It might start snacking on it and gravitationally pull in matter from that other star to the point where this dead star then gets massive enough that it itself then triggers a supernova and explodes all out everywhere as well. What we see in all the beautiful supernova imagery that I absolutely love is the glowing explosions of these supernovas, the supernova remnants that are left over because they're heating up all the material around them, and then they glow in many different wavelengths, but especially in X-ray. And one of my absolutely favorite telescopes that helps us get amazing images of all these supernovas is the Chandra X-ray Observatory. Perhaps the most famous image of a supernova that's gone around, whether or not you knew it was a supernova remnant, is that of the Crab Nebula. And no doubt it is a gorgeous image. It was taken by the Hubble Space Telescope, and in 1999 and 2000 it captured just this absolute beauty that's around 6 light years across. And you've probably seen it everywhere. It gets utilized in schools and in movies, all sorts of places, because, well, it just is amazing to look at. And this is what I love about supernova imagery in general, is that you get these beautiful images and you really start to wonder what happened in outer space to create these beautiful patterns. You'll also notice in a lot of supernova imagery that they use beautiful colors. These colors are representative. So these colors are representative of things like either different elements or different wavelengths, or sometimes a combination depending. So definitely always look at the caption of different supernova images to see what different colors represent. In the case of the Crab Nebula, different colors are representing different elements like oxygen or sulfur. What's really cool about the Crab Nebula is that despite being 6,500 light years away from us, you can still technically see it in the night sky with a pair of binoculars if you go looking. Farther away, at 11,000 light years away from us, is a supernova remnant known as Cassiopeia A. And I like Cassiopeia A personally because of just how much we know about it. It's one of the most studied supernova remnants out there, and we know so much about it. And because we know so much about it, we can really explore it in all sorts of dimensions. Several years back, a cool project at Harvard called the Astronomical Medicine Project investigated Cassiopeia A using MRI brain slicing technology software. So instead of getting a 3D fly-through of a brain, they actually produced a 3D fly-through of a supernova remnant, which was the very first time it had ever been done, which is just a really cool story behind how we got some really cool imagery for Cassiopeia A. Nowadays, we don't just have a 3D fly-through of Cassiopeia A, but you can actually have a full VR experience of flying through Cassiopeia A yourself in a VR headset, which is just really fun. I'm really excited to have things like Cassiopeia A in VR because I think it's really difficult to wrap our heads around just how much is going on inside of a supernova explosion. They're beautiful photos, but to actually experience them in different ways might give us better insights into what's actually happening in these supernova explosions. For example, from Cassiopeia A itself, it produced 70,000 Earth masses of iron. So if you can imagine 70,000 Earths of iron, that's what it produced. It also produced 1 million Earths of oxygen and 20,000 Earths of silicon and 10,000 Earths of sulfur. That's so much to wrap your head around that at minimum, you really need to explore it in VR to really at least try to understand all these amazing things that are happening way out in our galaxy and beyond. Another favorite supernova remnant of mine is the Tycho supernova. And the Tycho supernova is really cool because it has this almost marbling-like pattern in it. In fact, researchers actually consider this to be like a clumping-like pattern, and they're trying to figure out why it has a clumpy nature to it, why all the clumpy brightness to it. So its beauty is actually also the beginning of trying to figure out its story as to how that happened. Researchers believe that maybe, perhaps, instead of one single explosion happening, perhaps there was a string of multiple explosions happening in different locations that led to a pattern like this. And it's certainly possible because how Tycho started its supernova explosion was by being a white dwarf that was snacking on a nearby neighbor before exploding it all out into the universe. Another awesome supernova remnant is SN 1006, named such because it was seen by humans in the year 1006. It's thought that this supernova came from 7,000 light years away. So it took 7,000 light years to reach us here on Earth in the year 1006. And it's thought that it's in fact the brightest supernova seen by humans in recorded human history. You can still see it using telescopes like the Chandra X-ray Observatory because it's still lighting up X-ray, optical, and radio wavelengths. And its explosion is totally massive, measuring in at 60 light years across. Another supernova that I enjoy staring longingly at because I'm a total nerd, is the supernova E0102. Okay, despite its uninspiring name, its beauty is totally inspiring. E0102 exists in our tiny neighbor galaxy, the Small Magellanic Cloud, named such because if you are in the southern hemisphere, you can actually see it in the night sky with your naked eye. It looks like a tiny little cloud in the night sky. What is glorious to think about in terms of a long time scale is the fact that the explosion from E0102 created enough oxygen to supply thousands of solar systems. Thinking about that and thinking about all the things that these supernovas go on to create is just kind of the magic of them. Not only are they gorgeous to look at, but it's also fascinating to think about the stories that led them to be the way they are and all the things that they're going to be creating in the future just by exploding and propelling new elements out into the galaxy. I just really love thinking about supernovas as being part of an ecosystem, a cosmic ecosystem, but similar to how flowers and plants and other things and gardens and yards and sidewalks are recycling themselves and giving life to new things, supernovas are doing the same, just on a very, very large scale. Okay, that's it for me this week, space friends. As always, there are links in the YouTube description below. Also, a shout out to some of the really awesome patrons. If you haven't become a patron yet, head on over to my Patreon campaign, and I will see you all next week. Remember to always be exploring.